Okay, moving on to pumps, orifice, and weirs. Well, first of all, let me turn these weird conduit lines right back off there for a sec. Let's see, that's single symbol line, simple line. Yeah, there we go. Apply. Okay. Yeah, just get that off of there so that it's not so distracting. And let's start with pumps. Okay, so pump data, right click, open attribute table, and doc. And pump data, so you'll need an individual name. Again, you don't need these two. Initial status would be on or off. This would be, if your initial status is off, this would be your start depth, and you might have a stop depth. I mean, this could be backwards. It doesn't really matter, I don't think. Pump curve would be your pump curve name, and this would be your pump curve type. So let's go to again to the swim GUI because they have pretty good documentation for pumps. And what you'll want to do is come in here and just enter pumps and pump properties. So there are 5 types of pumps. So if you don't establish a pump type, then it becomes an ideal pump, meaning that no curve is required. It will take all of the inlet, all of the flow at the inlet node and move it to the outlet node. So it's going to be used for design purposes, okay? Type 1 would be an offline pump, and the rest, type 2, 3, and 4 would be online pumps. So offline pump would be like a pump with a wet well, and it's a staged, incremented flow. So you're given a volume of the wet well is given a volume, and then you're given a flow here, okay? And so it says if an online pump, there's something about an online pump, like a type 1 pump, is it can only have one node connected to it, I think, is the key to an online pump. It can only have like one node connected to the link, I think. Something like that. I don't know. I would say get an example from OpenSwim or from maybe ChatGPT. Okay, type 2 is an inline pump where the flow increases incrementally. So it's a flow depth, but it's in steps. And then type 4 is a flow depth relationship, but it's linear, like it's interpolated, continuous. And then type 3 is a differential. It's a head and flow differential. So it would be head on the upstream node and then flow through the pump to the downstream node. So pump curves are kind of a different topic, so we're going to cover those in the next lesson when we start putting all the data together. So let's focus, let's get back here, make sure we covered everything. So curve type, yeah. And so once we calculate our pumps and calculate everything, then we'll set up the pump curve data over here, which is exactly the way you do it in the storm drain GUI too. You set up the pump feature and then you set up the pump curves, okay? All right, orifice. So this, again, this is typically maybe an orifice. You might see these connected to a manhole, or like you might see an old underground like box culvert or something that has since been paved over and turned into a storm drain feature, and it has an orifice associated with it. So that's when you'll see these kind of underground orifice things. And so they need some specific information. Let's doc this real quick. Obviously, individual name. The type, is it a side or bottom? The shape. Let's go ahead and go back here to swim so we can see some of these features. So let's go ahead and click on our orifice right here, and you can see that we have cistern 1 and 2. Those are inflow nodes. So this is the name. These are the upstream node, downstream node. It's a side type, or it could be a bottom orifice. And the shape is circular or rectangular closed. Those are the only allowable shapes. This is the shape of the opening, the height and width. That's the shape of the opening. The inlet offset, this is the offset from the invert of the node, or sorry, from the inlet the invert of the system up to this geometry, this opening geometry. That's what this offset is. Discharge coefficient, whether or not it has a flap gate, and then if it opens or closes at a given time. And that is in hours. So what does that say? Okay, that's Orifice. Let's see, did we miss anything? Okay, so we got the shape, the height, the width, the offset, the Q coefficient, whether or not it has a flap gate, and whether or not it opens or closes at a specific time. All right, let's go with Weirs. I haven't ever seen an underground weir. You know, typically when you see a weir associated with a storm drain model, it's associated with above ground data like a channel or an irrigation ditch or something like that. So I know they exist, I just have not seen one. So I would suggest to you that if you see a weir in an INP file, challenge it and make sure that it's not related to, because if you had an INP file that had surface modeling data in it, such as a channel, open rectangular channels or open trapezoidal channels or something like that, you'd have to take that out before you connected it to Flow2D. So if you see a weir in an INP file, challenge it. All right, let's go ahead. So we got name, type, height, length, side slope, inlet offset, Q coefficient, flap gate, N contraction, N coefficient, and then shape. Okay, let's go ahead and check these out in EPA Swim. Is just a lot easier, and I have one right here, Weir 1. And so you can see individual name. The types are transverse, side flow, V-notch, or trapezoidal. Height and length and side slope is the dimensions of the opening. Inlet offset is the invert of the structure to the opening. Discharge coefficient, and no, it does not have a flap gate. N contractions and coefficients if it has like contractions after the water flows through the weir. Okay, so that is a weir. Again, haven't really seen one of those that's underground, so I haven't really officially used one of those. So this one here in the project is just fake. So I think that's basically it. So let's go ahead and just check this out real quick. So again, pumps tells you that, again, that's a string. Initial status, that's a string, it's on or off. Start depth, shut off depth are real. Curve name is a string, pump type is a string, and if the fields aren't required, and if you assign the link node button, it will fill in this data. Okay, and then Orifice, you can see here the different types of variables in the Orifice and the different types of variables for the Weir. Oops, are my tables backwards? Yep, my tables are backwards. Sorry about that. I'll have to sort that out later. Okay, all right, and that should be it for pumps, Orifice, and Weirs.